Alright, in this video we're going to start going over the second test. So the first question asks to describe the transformation of the parent function, and this function is in vertex form. Some general rules we had to remember are that inside the parentheses, that's our left and right movement. Outside the parentheses with the k is our up and down movement. Inside, a plus h means left, a minus h means right. And outside, a plus k means up, and a minus k means down. This a value out here is going to tell you the direction the graph opens, and it's going to tell you if we have a stretch or a shrink. So for this problem, the negative out in front, that tells you that we have a reflection. The 3 tells us it's a vertical stretch. And then using these rules, the plus 2 tells us we're going left 2, and the minus 4 tells us we're going down 4. Okay, over here we have a reflection. We have a vertical stretch by 2. We have a right 3, and we have a down 4. Okay, those are our description. For our vertex, we look at the h and k value. So this graph, since it went left 2, down 4, we think about what that would look like on our graph, left 2, down 4, that would put our vertex at -2, -4. The axis of symmetry is always the x value of the vertex. And then our y-intercept, no matter what form the equation is in, we plug in 0 for x. So we have -3 times 0 plus 2 squared minus 4. So -3 times 2 squared minus 4. Follow order of operations. We have to do our exponents before we multiply. So this is -3 times 4 minus 4. So -12 minus 4 gives me -16. X was 0, y is -16. For this one, again, if we're moving 1, 2, 3 to the right, and we're moving 1, 2, 3, 4 down, that puts our vertex at +3, -4. Axis of symmetry is always x equals 3. Y-intercept. We make our x value 0, and we follow order of operations. When you square a negative number, that becomes a positive, because it's -3 times -3 gives me +9, and then I have -18 minus 4, which gives me -22. So 0, -22. Okay. This, for number 2, this is in intercept form. We're identifying our x-intercept, axis of symmetry, vertex, and y-intercept. So when it is in intercept form, we take our factors and we set them equal to 0. This is going to give us our x-intercepts. We solve, so x equals -2, and we solve this equation, x equals 4. If we were to sketch this out, we'd have a point here at -2 and here at 4. So -2, 0, +4, 0. For our axis of symmetry and vertex, we need to figure out what the middle would be between these 2 points. In order to do that, you can add up your x's and divide by 2. You're going to get 2 over 2, which is 1. You can also, with something this small, just count on your graph, and you could tell this is going to be the line that would split your graph in half. So we know our axis of symmetry is 1. That means our x value of our vertex is also 1. So we can get our y value by plugging in our x value to the equation. So our equation is 3 times 1 plus 2 times 1 minus 4. Follow order of operations. We're going to get 3 times negative 3. We get negative 27. So our vertex is 1 comma negative 27. Our y-intercept, just like we did for the previous problem, you plug in 0 for x. Follow order of operations. Multiply everything together. 3 times 2 is 6, times negative 4 is negative 24. So 0, negative 24. Okay, on this one, same process. X-intercepts. We set our equations equal to 0, and we solve. X equals 8, x equals negative 2. 8, 0, negative 2, 0. We find the middle of these, so we add them up, and we divide by 2. So we have 6 over 2, which is 3. So our axis of symmetry is x equals 3. Our x value of our vertex is 3. We plug in that x value, and we can figure out our y value. So order of operations says do what's inside the parentheses first. And we get negative 50. Our y-intercept, we make x 0. So we've got 2 times negative 8 times 2 gives us negative 32. So 0, negative 32.